Hi guys, thanks for joining me today. I know that Wednesday is not our typical day, but Monday I didn't have a voice, and Tuesday I was really sick as well. So it's kind of been a bummer bit of a week for me. So I hope that you guys are all doing better than I am. But today's session we're going to cover 6.5, which is complex number exponents. I'm going to be doing a couple problems from your checkup itself, so make sure that you're taking really good notes, and this should help you kind of get through this very last section. We are still going to have a live session next Tuesday, and the date for that would be, let's see, next Tuesday will be the 27th. And during that session, I'm going to be going over some sample questions that you're going to see on your Unit 6 test. So remember, there's no final exam in pre-calculus. You guys have done a fantastic job the whole semester, so I do not have a final for the class. We will just have a test for this unit. So please join me next Tuesday for some sample questions of what you will see on your test. So let's go ahead, we're going to jump right in and get started. I shared the PowerPoint with you through file transfer, so if you want to print that out and write right on top of it, feel free to do so. Today's essential question, we are in week 18, and it says, when given a complex number like 3 plus I to the 6th power, how do you know which quadrant the reference angle will lie in? Because in order for us to take this complex number and change it to polar and then change it to rectangular coordinates, we have to be able to know what angle we're talking about here. So we'll be talking about how you know a little bit later on today. Here are just some quick topics that will be covered on the quiz today. The majority of these we are doing together. Oh, right here? There you go. No problem, and I always put up the essential question again at the end as well. All right, just let me know when you're ready and I will move forward. Great. Okay, so here are some topics that you'll see on the quiz, and at the end of today's session I will turn on the roaming feature so you can come back to this page if you want to. Basically we're going to do all of these top half together today. The only ones we're not going to get to is unity, so that will be the only one that we're not covering during today's session. So again, after today's session, I'll turn on roaming so that you can come back, because some of these probably won't make sense until after we study them together today. And hey, this is a French name. I've heard different people pronounce it different ways. De Mauvoir, de Mauvoir. One of those ways is probably correct since he's French. Okay, so here's his theorem. And what's great about his theorem is that he is teaching us a way to solve problems when I have a crazy exponent. Think about what we used to have to do in Algebra 2. If this was to the 3rd power, I would write this thing out 3 times, and you're doing a ton of foiling, a ton of combining like terms, but de Mauvoir or de Mauvoir, he is going to help us with a shortcut method. So one key thing to using his theorem is knowing how to find R. Let me draw you a quick picture just to remind you guys how we find our R. So here, pretend I'm on a unit circle here. Here's my X, here's my Y, here's my R. So R would be the hypotenuse of my triangle, which is how they get X squared plus Y squared equals R squared. So to get R by itself, this is just Pythagorean theorem. You take the square root. So this is going to be crucial to us in order for us to be able to write our formulas in this manner. Take a peek at what's happening to your end value, to your exponent. All they're doing is taking their exponent and putting it in front of theta each time. That's pretty easy. So we'll be practicing this today. And then here's just a couple other things that we have learned in the past. We're not so much using most of these in today's session, but we will be doing this tangent. So when we talk about how do you know what quadrant that reference angle is going to be in, we're going to be using this tangent equation today to figure out what quadrant. And I'll be practicing with you on the next slide. So let's jump in and let's try one together here. My question says, change from complex to polar form. So here's my example problem. Let me give you just a minute to get that on your paper. So we know that this is complex because it still has an I in it. This one matches with my left-hand side right here, and they're wanting me to change it into polar form. So by the time we finish up polar form, I guess we could still have I's in polar form too, but complex form is just when it has an exponent and has an R out in front. So what we have to do is we have to figure out which one's R. So your R's out in front, which one's N, your N's your exponent, and then we just have to change the format. So we're going to say 2 squared times cosine 2 times 60 plus I sine 2 times 60. So let's take a peek at what I did. And Dakota, you're absolutely right. You typed it in perfectly, but just in case anybody has a question, so you take your R, you put it out in front, you take your N, you make it an exponent, and then in our problem, your N has to go in front of your theta. So since my N was a 2, I have to put my 2 in front of each of my thetas. So here I would get 4 cosine 120 plus I sine 120. And at this stage, it's considered polar. This is your polar form. If they wanted it in standard form, you would finish working it out, meaning you would work out what cosine 120 is, what sine 120 is. You could use that chart that I gave you a while back that gives you each of those, or you could use your calculator. But in this case, leaving it in polar is fine since that's what it asked us for. But I just wanted you to know if it asked you for standard form, that just means take it one step further until you get these answers down there. Okay, so great job. So far, so good. This is number 5 from your checkup. So let me give you a second to copy this one down. Again, this is in complex form, and this time my question is to take it all the way to standard form, which means we're going to have to do polar form first, and then we can change it into standard form after that. So let us remind ourselves what our format is going to look like. It'll be R to the N cosine n theta plus I sine n theta. So let's figure out which one's my R, which one's my N. So here's your R out in front, and your N is always your exponent. So far so good, picking out what things are. So R is always out in front, your N is your exponent. So now I just got to plug and chug here. So I'm going to have 3 to the 5th power cosine. Now my N was 5, so I'm going to have 5 times my theta. So if I'm coming back to my original problem, my theta, or my angle, is pi over 20 plus I sine n theta, so 5 times pi over 20. And then from here we just have to simplify a little bit. So my 5 and my 20, those can reduce to a 1/4, or in other words, pi over 4. And I can do my 3 to the 5th also. So 3 to the 5th, 243, cosine pi over 4, plus I sine pi over 4. Any questions how I got to here? Okay, so 243, I worked out 3 to the 5th. So 3 times 3 times 3 times 3 times 3. 3 to the 5th. I was just simplifying a little bit. Good question. Any other questions how I went from pink to pink? And at this stage it's called polar form. So right here, good question. So let's check out how did this happen. So in here this is n times theta. So since my n was 5, right, my n was 5, I had to do 5 times my theta. So my theta was pi over 20. So let me do a little multiply in here. Let's write it on the side. It's just a kind of like a fraction times a whole number. 5 times pi over 20. Remember, when one of them is not a fraction, I can really put it over 1. So I can go straight across the top, straight across the bottom. So I get 5 pi over 20, and 5 over 20 reduces to 1 over 4. No, I'm glad you're asking, because I'm sure other students will have the same question. So I'm glad that you're asking. So this portion, just put the 5 under a 1, go across the top, across the bottom, and it reduces to pi over 4. Excellent. Yep, that's what we're here for, right? That's what this time is all about, asking lots of good questions. So at this point, we're at polar form, which is not quite what my question number 5 is asking me on the checkup. It wants me to take it all the way to standard form. So all that means is I got to keep reducing a little bit more, meaning I have to get rid of my cosine pi over 4 and my sine pi over 4. So if you guys look at the chart that I gave you a while back, we know that cosine pi over 4 is root 2 over 2. There's still that 243 out front. And then, oops, and then sine of pi over 4 is also root 2 over 2. So the last thing that I'm going to do, sometimes I'll leave it like this for you on a test, and sometimes they are going to want you to distribute this 243. So on this particular question, they're going to take it all the way down where you distribute. Now here's another good question. How do you know whether to put in a radian or a degree? It depends on what the question is asking you for. Meaning, if you look at your multiple choice options and you see that it's in degree, then instead of doing root 2 over 2, I would say 45 degrees. But if on the test it has it in radians, then you would put the radians in there. So there's no one telltale way to know if they want radian or degree. You're just going to have to look at the answers. Because if we were in a traditional classroom, I would accept either one as being correct. But since you're taking your tests online, whatever they have as their answer is the one you're going to have to select. Obviously on the free response stuff, I would take either one. Exactly. Yep, exactly. So let's go ahead and distribute this 243 just so you can see the final way that it's going to look like. They're going to have 243 times root 2 over 2 plus 243 times root 2 over 2i. So they really just stuck the 243 out in front. Not very exact, I know. So this, it would be the standard form at the very bottom. Okay, you did great. I think we should try another one. So let me give you just a second to copy this one down. This is number 10 on the checkup. And again, this is 6.5 that we're working on right now. Oh, does the checkup have a 5 in there? Oh, sorry. Well, this one's really close. Okay, so my first question that I want us to think about is on the last one, let me skip back a slide here. See, on this last one, I had an R and I had an N. I don't have that this time. I don't have an R and an N. This time I just have a coordinate raised to the 6th power. So this time I have to find my own R. Do we remember how to find our own R? Okay, to find our R, it was the square root of x squared plus y squared. So your x is your first term, so it's going to be negative root 3 squared. And the second one is my y term, so it's going to be a 1 squared. Remember, your x term is always the first term, your y term is your second term, so it's the number in front of the I. So the number in front of my I is a 1, so that's why I put in a 1 there. So negative root 3 squared is going to be a 3, and 1 squared is a 1. So the square root of 4 is going to give me 2. So I found my R. My R is 2. Any questions on how I found R? Okay. So let's remind ourselves of our formula. It's R to the n cosine n theta plus I sine n theta. We just found that my R was 2. And looking up at my problem, can you find my n in my problem? What's my n? My n is 6. Now, what I'm supposed to do here, though, is I'm supposed to do cosine times n theta. So this will be 6 times theta plus I sine 6 times theta. How am I going to find theta? That's how we need to start talking about what quadrant is this coordinate in. Are you okay till right here? Till my red star? Are you okay with how I got there? Okay, so let me help you out. So far so good. We know how we got our R. Now, here's how you figure out what quadrant it is. You ready? This is where you need that tangent. Tangent theta equals B over A. Your B in this problem was 1. Your A in this problem was negative root 3. I need to find where on my unit circle, at what degree, is tangent 1 over negative root 3. The thing is, if I'm looking on my chart, I don't have 1 over negative root 3 anywhere on my chart. That's because I'm not allowed to have square roots in my denominator. So let's rationalize the denominator. Just stick with me, you're going to see where I'm going. Remember, to rationalize the denominator, you're just multiplying it by itself, and whatever you do to the bottom, you have to do to the top. So I get negative root 3 over 3. So when you have problems like this, there are 2 steps when they do not tell you your R and your theta. Number 1, you have to find R. That part was easy. Number 2, we have to find theta. And here's how you find theta. Every single time it's tangent theta equals B divided by A. So 1 divided by negative root 3. So I'm looking for where on my unit circle does tangent equal negative root 3 over 3. So if I'm looking at my chart that I have here, it's hopefully the same chart that you guys have kept handy, there are 2 places where tangent gives you negative root 3 over 3. It is at 5 pi over 6 and at, tangent. 5 pi over 6 and 11 pi over 6. Only one of those 2 is my correct theta. Here's how you figure out which one it is. We have to ask ourselves what quadrant is our point in. Here's how you can tell. If you go negative root 3, that is to the left. If you go positive I, that is up. What quadrant are you in? Okay, if you go negative root 3, that is to the left. If you go positive I, that is up. What quadrant are we in up here? What's negative root 3 plus I? Quadrant 2. Which one of those points is quadrant 2? This one. So that is your theta. We are going to replace our theta with 5 pi over 6. Okay, let me give you a minute to simplify that and let's see what you get. guess I need my talking back on. So let us simplify this a little bit. Let me hide some of my nonsense here on the screen. There we go. So 2 to the 6th is, let's figure out what that is. 2 to the 6th is 64. Cosine, now look what's cool, the 6 and the 6 are going to cancel, right? So we're going to get 5 pi plus I sine 5 pi. Hopefully so far so good. So you just had to cross off the 6 with 6, 6 with the 6. Very cool. They go away. Kind of nice. So at this point, this is considered polar. And let's see, did they want us to take it all the way down? Yep, so let's finish this one up all the way to standard form. So cosine of 5 pi, if you plug that in your calculator, you get -1. And sine of 5 pi is 0. So I times 0 is going to be 0. So we're going to be left with 64 times -1, which would be -64. So that would be polar form and standard form. So what I want you guys to remember is anytime they give it to you in this format like this, you have to find R and you have to find what quadrant they're talking about. Remember we had that step 1 and the step 2. R we've been finding forever. X squared plus y squared, square root of that, that's your answer. Step number 2 is how you find your quadrant. This is your essential question for the day. So number 2, how do you find your quadrant again? You're going to look at your coordinate and ask yourself, where would this point be located? If you go -√3 spaces and then a positive I, that's in your second quadrant. To figure out what the actual value of theta was, you're going to always do tangent theta equals b over a, and you're going to figure out where does tangent equal that amount. And in this case, it was at 5 pi over 6. So let me wait for just a second. I see you typing. We're going to practice those 2 steps again on the next slide. So when I look at my coordinate here, how do I know what quadrant this coordinate is in? That's my essential question. How do I know what quadrant this coordinate is in? I go -√3 spaces and then plus I spaces. How do you go a negative for your x and a positive for your y? Negative for x, positive for y, you end up in quadrant 2. So you have to look at your x value and look at your y value. That's how you know what quadrant it's in. So just one sentence along those lines is going to be just fine, and I'm going to know you're gonna understand. So let's practice this one together, Dakota. If I look at this problem right here, -1 minus I, how do you know what quadrant that's going to be in? Because -1, we're going to go which direction? Yep, we're doing this one together. So for -1, which direction do you go for -1 on your coordinate plane? Let me draw a little one up here. -1, you go left. How about if your I is a -1? Then you're going to go down. So this one is in quadrant 3. To know what quadrant it's in, you just have to look at the signs in front of your terms. Exactly. Exactly. So we know that this one's going to be in quadrant 3. Just going to highlight that. Because again, it's a -1 left, -I down. So we know it's going to be quadrant 3. So when I give it to you like this, this is just like the last problem. We're just going to try again. Remember, there are 2 things you need to define. You need to find R, and you need to find theta. So let's all find R together first. Let me give you guys a second to do that on your paper. Perfect answer. So we're going to plug in -1 for our x and -1 for our y. So -1 squared is a 1, -1 squared is a 1, so 1 plus 1 gives us √2. Good job. So you found R. Now before I show you any of my work, let's do our step 2 together. Step 2, do I have some space? Oh good, I do have space. Step 2 is to figure out what our theta is going to be. What's theta? So to figure out theta, we always are going to plug it into tangent theta equals b over a. So in this case, my b was a -1, my a was a -1. Are you okay with where b and a come from? B is just your second term, a is your first term, so b and a. So in this case, my tangent equals 1. So let's look on our chart. Again, if you guys need me to go re-give you this chart, I can, where you guys look this up. But this is just your formula. Tangent theta equals b over a. This is always how you find theta, always. What do I plug in for b? You go back up to your original problem. B is your second term, that's a -1. A is your first term, that's the -1. So -1 over -1 gives us 1. This is always the formula that you use for step 2. Always. I like the word always in math, something that always works. So right now we're at tangent theta equals 1. I need to look on my chart and find where does tangent theta equal 1. Go ahead, I'm waiting for you to type in your question. Or do you have a mic? Do you want the mic? So there's 2 steps. Step 1 is how you get R. Are you good with how we get R? R equals a squared plus b squared square root. Step 2 is how do you get theta? You always use tangent theta equals b over a. This is just your formula you're going to use every single time. All you have to fill in is b and a. Where do b and a come from? Our original problem. B was -1, a was -1. Yeah, that's right where we're at. Yep, so tangent theta equals 1. So we need to figure out where does tangent theta equal 1? Well, at pi over 4, and at 5 pi over 4. They like to use radians. They most of the time will use radians. So here's where we have to come back to, well, which theta do I use? Because you have 2 thetas going on here. That's when I ask you the question, what quadrant is this in? And from the very beginning, the very first thing we did on this slide is we figured out it was in quadrant 3, because it's a -1, -I. So which one of these 2 is in quadrant 3? Not pi over 4. Pi over 4 is in quadrant 1. So 5 pi over 4 is the one in quadrant 3. Right, this is why you're not using your calculator. You're using that chart that I gave you guys quite a while ago, but you're going to use it all the time. Let me share it again right now. Let me go grab it for you. It's a super handy dandy chart that I want you guys keeping close by. Hang on, I'm just looking for it. I might have to find it later. I don't want to take up too much time here. Yeah, I will find it and I'll send it to you. But yeah, it's the best chart ever. And I said, print it, print it, print it like a million times. That way you'd have it all semester. So let's just go back over what we did. They give us a coordinate. We recognize what quadrant it's in. There's 2 steps. Step 1, find R. Step 2, find theta. Once you find R and theta, now we can go through and write it in the correct formula. So we found that our R was a √2. And where is tangent? Tangent is 5 pi over 4. Oh, I guess they were using degree in this one. So 5 pi over 4 is the same as 225 degrees. 225 degrees. So that's what they're going to use in this problem. And again, you're going to know which one is right based on how they have the answer on the test or quiz. When you're working through a problem, you can choose either method that you want because they are both correct. And if it's a fill in the blank, I will take either answer as being correct. So if you like degrees or if you like radians, it's up to you. I'll take either one. So let's go over how they're going to write it. So we're going to put our R out in front, and my N was 5. R out in front, my N is 5. So from here, this is where we started our last problems on the last 2 slides was here. So this was just getting us to this point. So now do you remember what we do with our exponent? We have to put it in front of each theta. So we're going to raise the square root of 2 to the 5th power. Yep, this is finding. Okay, that was weird. So this is us solving complex roots right here. So we're taking what they give us and we're changing it into rectangular form using the Moule's theorem. So at this point we're going to do square root 2 to the 5th power, and we're multiplying each theta times 5 times our n. By the time we simplify, square root 2 to the 5th power is 4 root 2. And we get cosine of 1125 plus I sine 1125. Okay, just to finish that off, cosine of 1125, that is quite a few rotations around your unit circle. If you plug that into your calculator, if you're in degree mode, so if I'm going to my mode and I'm in degree mode, I have to change mine over because we use degree and radians all the time, so make sure you're in the right one. If you do cosine 1125, you get 0.707. Exactly, yes, good question. So you're going to get 0.707. Now, if you're not comfortable with knowing that 0.707 is root 2 over 2, then what I recommend is taking this chart that I'm going to share with you again today and changing some of those radians into decimals. So for instance, root 3 over 2, if you try typing that into your calculator, root 3 divided by 2, you're going to get 0.866. That way you know that these two are equivalent. Just like if you type in root 2 over 2, you're going to get that's 0.707. I just want you to recognize that these are equivalent because we're going to see them so often that I want you to be able to go back and forth. So they just changed cosine 1125 to root 2 over 2, and same with the sine to root 2 over 2, and then just reduced. So you'll have lots of chances to practice this on your checkup. But these were at least a couple questions for you. Okay, so before we end today, I do want to do one more with you. Let's talk about nth roots here. So this is just a lot of jargon until we get to a practice problem here. There is a formula that we're going to use when we're finding nth roots, and it's right here. And it does go over it in great detail with you in the online lesson, but I want to show you there's 2 ways to write it. You can either write it theta plus 360 degrees times k divided by n. Think about what 360 is. 360 is a whole rotation. Hopefully everybody agrees with that. So your angle plus a whole rotation. Your angle plus a whole rotation. But there's another way to write a whole rotation. So I want you to know that you can also say it in terms of radians. It would be theta plus 2 pi k. Theta plus 2 pi k. K is going to be how many terms they're talking about. So a couple of times during this semester we've had some formulas with k in them. K is just how many terms you're talking about, which I know it's kind of weird because we have k and we have n. So in this case, your n is talking about your number of roots. K is talking about your number of terms. So n is going to be your number of roots. Think about it like this, because here we're talking square roots. They're not going to tell you k, but here's how you figure out k. K equals n minus 1. So if you're talking about 5 roots, you're going to talk about 4Ks? Good question. So if you're talking about 5 roots, because remember n is your number of roots, man, Illuminate is not my friend today. Okay, so n is your number of roots. K is always going to be 1 less than the number of roots. So if your n is 5, then your k is going to be 4. They have to give you n or k. Yeah, they have to. Otherwise, you just have lots of variables in your problem and you can't do anything with it. So you're going to see in just a moment, k is where you're actually going to plug in a 0, a 1, a 2, a 3, a 4. You're going to do it multiple times. So if my k is 4, that means you have to do 0, 1, 2, 3, 4. If your k is 2, you'd have to do 0, 1, and 2. So it will make more sense once we try a problem in just a moment. It's sort of like the summation formula where you had to do it multiple times for different k terms. It's the same thing here. So let's try this one. Find the square roots of 1 plus square root of 3i. So this will be our last problem for the day. Okay, so first things first. We have to switch it into trigonometric notation. I'm going to show you in just a minute. So how did I go from the left to the right? I had to find r. Remember r, x squared plus y squared. So that would be 1 squared plus root 3 squared. So 1 plus 3 is 4, square root of 4 is 2. That's how they got 2. Because by this time on the online slides, they're probably skipping quite a few steps. So I want to make sure you knew how they got their r is 2. Are we okay with how they got r is 2? Step number 1. What was your step number 2? You have to find theta. How do you find theta? Tangent theta equals b over a. So if I plug in my b and a, sorry, they're skipping a ton of steps here. Your b is root 3, your a is 1. So we have to figure out the spot. Where does tangent theta equal root 3? Tangent theta equals root 3 at 60. How did I know it was in the first quadrant? Back to our essential question. How do you know that this is in your first quadrant? Because it's a positive 1 and a positive root 3. Positive 1, positive root 3 is in your first quadrant. Hopefully the pieces of the puzzle are coming together better for you guys now. So step 1, you always have to find r. Step 2, you have to find theta. And this is how you find theta each time. B over a. Tangent theta equals b over a. Smiley face so far? So far so good? R and theta? Excellent. Okay. Next step. Now we have to use the nth root theorem. So it's just plugging and chugging into this new theorem here. So let me give you just a minute to write that down and then we'll go over the pieces of the puzzle here, okay? Just let me know when you have that on your paper. I'm going to show you the 1/2 in a minute. Remember that this is your exponent. How did I know that my exponent was a 1/2? We have to look back at what the question asked. It said find the square root. What kind of exponent represents a square root? 1/2 is square root. Do you remember that those two are the same? Well, 1/2 is a square root. So it's still our same formula. It's still r raised to the n, but in this case, my n is a square root. How do I represent a square root as an exponent? 1/2 is a square root. Do you guys remember what a cubed root is? So square root is a 1/2. What's a cube root? 1/3. What's the fourth root? 1/4. Because remember, if here's your square root, I think it's telling me I've talked too much today. Okay, let me just remind you. If here is your square root and there's really a 2 there, we always ask ourselves what kind of exponent is on it. So 1. So we can write that as n to the 1/2. The 2 goes on the bottom, the exponent goes on the top. So a square root is the same as a 1/2. Cube root is the same as a 1/3. So here we are. So we're doing r, which we just found was 2. So my r to the n. What kind of exponent do I have this time? Since it's a square root, I'm going to put a 1/2. Then this is still the same as before. This is your n times theta. N times theta. So I had to do my n, which was 60, times my theta. Sorry, my theta was 60 and my n is a 1/2. So what's 1/2 of 60? 1/2 of 60. That's why they're showing the divide by 2, because it's times by a 1/2. So what we're going to do next is we're just going to simplify this. 60 divided by 2 gives us 30. 360 divided by 2 is 180. So again, we're just simplifying here. Instead of saying n2 to the 1/2, they're just writing it as square root of 2. They're just changing the format because it's the same thing. We're allowed to do that. So how are you going to find k? So this is my standard form right here. This is my generic standard form where I have a variable. I have a k. So now is where I have to plug in what my k is going to equal. So if k is 0, if I take a 0 and I plug it in for k, 0 times 180 would go away, 0 times 180 would go away. So I would get root 2 times cosine 30 plus I sine 30. Now if your k is not 0, let's say your k is 1, what would happen if I put a 1 in here? You'd get 30 plus 1 times 180. So 30 plus 180 would be 210. What would happen again if you plugged in a 1 for k over here? 30 plus 180 would be I sine 210. So since your r was 2, your k is 1 and 0. Remember that your k's are always going to be one less than what they're talking about up here. So this will make more sense as you practice some more. If my r was 5, then your k's would have to be 4, 3, 2, 1, 0. You're just trying different values for k and plugging them in. So that was a lot for one day. The main things, the main takeaways that I want you guys to get from today is that with these types of problems, step 1, you have to find your r, and step 2, you have to find your theta. So those are kind of the key biggies that I want you to take away from today. And the rest you should be able to do by checking out the answers and the steps on the checkup. We'll have one more study session together next Tuesday, but just a quick reminder of your essential question. When I give you a complex number like this, how do you know which quadrant the reference angle is going to lie in? Because by the time we do tangent theta equals b over a, you might have 2 answers. How do you know which one's the right answer? It's based on this. So I just want one sentence of you telling me how you know what quadrant it's in. All right, thanks. I hope that this helped you a little bit, and I will see you guys next Tuesday.